What's up?
It's Faisal. What in the world was that? Welcome back to my calculus playlist, where I'm gonna have 3 playlists organized with calculus 1, calculus 2, and calculus 3. So let's begin our first video of calculus 1. Today we will talk about what is a derivative. So knowing off the linear algebra you probably know already. How do you want to get the slope of a point? That is m. M is the rate of change. It shows, like, for example, you see this curve? This curve, it goes like kind of up at a pretty steady rate. Okay, let's see the slope between these 2 points. How much does it go up? What is the rate of change? It's called the rate of change. That's exactly what a slope is. So m, we know that the formula is y2 minus y1 over x2 minus x1. Now this right here is the point 4, 2. This is the function y is equal to the square root of x, by the way, just so you know. This is the point 9, 3. Bear with me. So the slope will be the difference in y versus the difference of x, or delta y over delta x. So that'll be equal to, well, the second y value is 3 minus the first y value, which is 2, over 9 minus 4, which are the difference in x values. So 3 minus 2, that's equal to 1. 9 minus 4 is equal to 5. So the slope is 1 over 5. Now, this is the average rate of change for these 2 points specifically. This is the average rate of change. But what if you wanted to find the instantaneous rate of change? So that is, like, not like at a single point, not between 2 points, the average. Well, if you wanted to do that, have this point be x, f of x. F of x is basically equal to y, technically. So we'll have x, f of x. And this, let's say they're separated by some distance called delta x. Okay? So this would be x plus delta x, f of x plus delta x. So these are the points. Now let's plug them into the slope formula. So I got my work down here. So the y values are f of x plus delta x minus f of x. Those are the y values. And then the x values would be x plus delta x minus x. These x's will cancel. So now we have this formula. This will give us the slope between 2 points on some distance delta x. Now, this will just give me the slope, the average slope, but what if we wanted to make delta x equal to 0? Well, if we try that, we'll get f of x plus 0 minus f of x, which is just f of x minus f of x, which is 0 divided by 0. And 0 divided by 0 is a big mathematical no-no, so we don't want that. But what we do want, we can have the limit. This is where limit comes in. So we'll have the limit of as of delta x approaches 0. So now we don't make it equal to 0, we keep bringing it ever so slightly closer to 0. So for example, let's do this for the curve y is equal to x squared. Now this is the derivative. The derivative of x squared is 2x. And we can plug any point into this formula, derivative. Now that we have this, let's say we want to find the equation of the tangent line. Here's the graph of y is equal to x squared. It's just a parabola. Now, let's say this is x equals 2. Y would be equal to 4 since 2 squared is 4. The tangent line would be the line that hits this line, kind of like that. You could just use the point slope formula. Here we have x or y1 is equal to 4. So y minus 4 times m. Now m, 2x is the function, right? So 2 times 2, that's 4. Times x minus 2, which is the x minus x1. So this is the equation for the tangent line and point slope. Another application of derivatives is finding the turning points of something like a cubic function. Let's set x cubed minus 4x equal to 0. Let's find the derivative of x cubed minus 4x. Now, I'm not going to go too much over the actual differentiation process, but just trust me, bro. It's equal to 3x squared minus 4. We'll talk about actual differentiation, like how to actually find the derivative in the next video. So let's set this equal to 0. Now let's find the y values for those. It's equal to minus plus 3.08. So now we can connect it. We can go like this, and then go like this, and like that. And voila! Now we know the turning points of this function. So it's just that easy. That's how you can find the turning points of a function. And there are many other applications. Related rates. There's a whole universe of derivatives. I hope you found it educational and you knew what a derivative is finally to understand calculus. That's it for today. If you enjoyed it, feel free to hit that like button, subscribe if you haven't already. If you join my Quora, it's in the description. Stay foxy and much love.